Hi everyone, in this video I'll discuss the length of the longest substring without repeating characters. For example, consider an input string ABCBAD. Now, in this string, the longest substring without repeating characters is CBAD and its length is 4. So, we need to return the output 4. So, this problem can be solved in multiple ways. The first way is using a hash map. We can solve this. So how do we do that? So now let's go through the process. Now let's index the input string for better understanding. So this is the input string. Now upon indexing, this is 0, this is 1, 2, 3, 4, 5. Now we need to find the length of the longest substring ending at each of those indices. Like, to solve this problem, we need to find the length of the longest substring ending at I equal to 0, ending at I equal to 1, I equal to 2, I equal to 3, I equal to 4, and I equal to 5. So for this, we need to declare a couple of variables. So first and foremost, we need to maintain a hash map to check if a particular character already occurred at a particular index. Now I need a hash map for this. So initially the hash map would be empty. It doesn't have any information. Now apart from that, I need to maintain a variable which maintains the length of the longest substring. So I'll name it as max length equal to 0. So initially I'll declare it as 0 since we have not yet iterated. And apart from that, I need to maintain one index. What is the use of this index? Because at every index I equal to 0 to 5, I need to find the starting index which makes that string the longest substring. So to simplify it, so let me first declare the index. So I declare index equal 0. The use of the index will be like more clear in the upcoming solution. So at I equal to 0, now let's check the character A. The character A is not present in the hash map. So we we need to first update the max length and then update the hash map. So the index is 0. The index is nothing but the we can call it as a starting index. Max length will be I equal to 0 minus starting index is 0 plus 1, which is equals to 1. Now in the hash map we can update the character A and its corresponding index. Now at I equal to 1. Now at I equal to 1, the character B is not at within the hash map. So first we need to update the max length. So the max length will be, since I equal to 1, it is 1 minus 0 plus 1, which is equals to 2, and we will be updating the hash map which is b comma 1. Now at I equal to 2, the character C is not at within the hash map, so we will update the max length. So which implies it is 2 minus 0 plus 1, which is equals to 3, and we'll update the hash map which is c comma 2. Here why are we doing I minus? This is nothing but I minus starting index plus 1. Why are we doing this? Because at I equal to 2, we know that from starting index 0 till I equal to 2, there is no repetitive character, and the max length of the string of the substring ending at I equal to 2 would be nothing but ABC, and its length is equal to 3. That is what it denotes. Now at I equal to 3, here comes the trickier part. So we already encountered the character B in the hash map. So simply for basic understanding, we can know that the length of the longest substring ending at I equal to 3 is nothing but CB. which is from indices 2 to indices 3, which is nothing but the substring CB. So how do we get that? If we go and retrieve the character B value from the hash map, we would get it as 1, and the starting index should be nothing but 2. How do we get that? Since we have got the value of the character B from the hash map, which is equals to 1, the starting index would be that plus 1. So starting index would be 2, and max length would be, so it would be 3 minus 2 plus 1, which is nothing but 2, but the length of CB is 2, but we are not updating the max length because we already got a max length which is 3, which is greater than 2. So we will not be updating the max length here. So at I equal to 4, I equal to 4, we already encountered the character A, and the value of the character A is 0, like the index at which it occurred is 0. But observe carefully here, we need to find the length of the longest substring ending at I equal to 4. So if we just simply go by the previous logic doing 0 plus 1, then it is not correct, because if we consider the substring from 1 till 4, there is a character B which already got encountered. So for this, what we need to do is, here comes the formula. So it would be math.max of starting index comma the hash map dot get of the character which we are checking plus 1. So this would be the formula over here. So in this case, we got hash map dot get of A is nothing but 0, 0 plus 1 is 1, but the starting index is 2. So the starting index would still be 2, because and the length of the longest substring ending at I equal to 4 would be nothing but CBA. We are not updating the starting index here because the starting index value which already got updated is greater than the hash map dot get of A plus 1. Because if we are considering the starting index as 1, the character B is already present at both indices 1 and 3, and it would cause it duplication. So we should only consider the starting index, the maximum value. The maximum value of starting index is 2, and would be only considering that. And the max length would be nothing but, here it is 4 minus starting index is 2 plus 1, which is equals to 3, which is still the same, so we are not updating it. So at I equal to 5, the character is D and it is not, so here we need to update the A comma 4, and I forgot to update the hash map for I equal to 3, B, it would be B comma 3 as well. So at I equal to 5, the character is D, we did not encounter the character D in the hash map, so we'll be updating the max length as 5 minus the starting index is 2 plus 1, which is equals to 3 plus 1, 4. So here it is max length is more, so we'll be updating the max length as 4, and we'll be updating the hash map. So that's it, we got the max length as 4 and would be returning the max length as 4, which is nothing but CBAD. So this is the solution. This is one solution using a hash map. Now I will discuss another solution using an hash set and a queue. So how do we do this? So initially hash set would be empty and the queue would be empty. So this would be a simple solution as well. So at I equal to 0, we encountered the character A. Character A is not present inside the hash set, so we will be adding it to the hash set. It is not present inside the queue, so we'll be adding it to the queue. So now we need one more variable, max length. So for every I, we'd be denoting the max length as the size of the queue, which is it is size of queue, which is equals to 1 at I equal to 0. Now at I equal to 1, which is B is not present inside the hash set, so we'll be adding it to the hash set. It is not present inside the queue, we'll be adding it to the queue. So max length is 2 over here. And what does this denote? the longest substring ending at B is nothing but the characters in the queue, which is nothing but AB. And at I equal to true, which is C, it is not present inside the hash set, so we'll be adding it to the hash set. It is not present inside the queue, we'll be adding it to the queue. The size of the queue is 3 and max length is 3, which is nothing but the longest substring without repeating characters ending at I equal to 2 is nothing but ABC. Now at I equal to 3, here comes the trickier part. We already encountered B in the hash set. So if we do hash set dot contains, it returns true, which implies that B is already present in the hash set. Now what we need to do is, we need to, like, first and foremost dequeue the queue until we encounter B. So what does that mean? We need to dequeue the queue from the beginning. We need to remove A, we need to remove B, and at last we need to add B. And inside hash set, since we are adding B, we need not remove and add it again, we can just keep it as it is to just get the information that B is present in the hash set. So here the max length will be size of the queue is 2, but we already have 3 which is greater than 2, we will not be updating that. So at I equal to 4, so I just one small minor change here. So while we are dequeuing the queue, so we dequeued the queue like A, we will be removing the A as well. So we'll dequeue the queue, we remove the B, and we are adding the B. So so it's like we are removing B from the hash set and adding it to the hash set. So it would be the same. So but we need to remove A from the hash set as well, since we are removing it from the queue. Now at I equal to 4, we got A is not present inside the hash set, so we'll be adding it to the queue. The max length is size of the queue, which is 3, it is the same, so we need not update that. So it means that the length of the longest substring ending at A I equal to 4 is CBA, which is the number of characters present in the queue. At I equal to 5, the character D is not present inside the hash set, so we'll be adding it. We'll be adding it to the queue. The max length is nothing but the size of the queue, which is 4. So we'll be returning the max length as 4. So these are the couple of solutions using hash map in the first solution and a hash set and queue in the second solution. So both of these solutions use O of n, time complexity is O of n. So it is solved in linear time complexity. Thank you everyone.